In today's lesson, we're going to combine a few things that you already know. I'm really not going to show you anything new, except for the fact that when we talk about solving a system of inequalities, so here we're graphing a system of inequalities. Graphing is the only way that we can solve a system of inequalities. So you're going to take all the skills that you already have. Alright? We want y to be by itself. So in the first one, we have that already. I got -1 for a y-intercept. -1, we have a slope of 3. Remember, it's 3 over 1 if you want to keep thinking that way. 1, 2, 3, rise 3, run 1. Okay, I'm going to connect these 2 points. And if I look at it, it's greater than or equal to. So that's going to be a solid line. So we'll go right through there and connect them. I'm going to extend it out the other way as well. So if you're using your ruler, you can do all that in one step. Next thing you have is y is greater than or equal to. So I'm going to test a point. I'm going to test 0, 0. So 0 is greater than or equal to 3 times 0 minus 1. 0 is greater than or equal to -1. And that is true. Having nothing is better than being in debt. Alright, so we have, this is the true side. So I'm going to shade to the left just a little bit. Alright, let's grab the second line now. Again, I have y is less than right now, so I don't have to do any solving. I'm going to use positive 3. And we're going to use the slope of -2 over 1. So 1, 2 over 1. And what you'll notice is these two lines don't meet up at one of those nice points. And I'm okay with that. And I have just less than. So all I need is a dashed line. And I'm okay that it's not a nice point because I'm not after a single point of intersection. I want to find out where all the points that they share are. So as I go through, again, I can test 0, 0. So 0 is less than 0 times -2 is 0, so that's gone. So 0 is less than 3. 0 is less than 3. Well, that's true as well. So that means I'm shaded on the side of the origin because that's where 0, 0 is. And what we're truly after here is the area that they share. So anything in red and blue here, which becomes the left side of what looks like an X. Right, so we end up with the left side here. Sometimes they're shaded both above or both to the right, or it ends up at the bottom. But in this case, we have everything to the left. And what that means is I can pick any ordered pair out here. So if I wanted to pick this ordered pair right here, -5 and 2, I could plug it into both of these for x and y, and they would be true. Instead of having a one-point solution where they meet, this is going to have an entire area that everything is true for these two equations. So again, nothing new, but I need you to understand the concept of what's going on. Alright, next one. Second equation is done already, so let's go ahead and graph it. So I have 1, and we have -1 for a slope. I'm going to put a third line. It just helps me line things up. And that one is going to be a dashed line. So let's get that set and extended. I do have a nice origin right here is available. So 0 is greater than 1. Well, that's false. So that means this point is false. So I'm going to go to the other side. So I just know it's on this side of the line. We have some work to do for the other equation. We have to get y by itself. So I have -2y is less than -5x plus 6. Right, I'm going to subtract 5x. That's how I get it over there. And I like to put it in slope and intercept form. And divide by -2. So y is now greater than, remember I have to change the inequality. I'm dividing by a negative. 5 halves x is positive, and -3. So I have -3 for a y-intercept. We're going to go up 1, 2, 3, 4, 5. And we're going to run 2. So here are the 2 points I'm going to connect. Dash line again. That looks pretty good there. And now we have to test a point. So if we're going to test, I have 0, 0, and what I probably want to do is go to the original. It's going to be easier that way. If I have 0 here and 0 here, so 0 minus 0 is 0. Is 0 less than 6? You betcha. 0 is less than 6. That's true. So we're going to be on the origin side of this line. Now the area is shaded twice, and again, every time we do this, we're going to end up with what looks like an X. It could be kind of funny shaped or whatever, but the area in the top middle, and I could keep shading up here and up here and up here. If I extend my lines, I'd make sure I stayed inside of it, but hopefully we're starting to get the idea. Alright, now for some reason when we start to take some information away, some people get confused. So one thing I can do here is put +0. That means I start at the origin for our first line, and slope is 2, so rise 2, run 1. And we have solid lines, so I got to change my line over here. And we're going to connect that back, extend it some more. Now the only trick that I have right now is I can't use the origin because it's on the line. So maybe I pick, let's go right here. So this is the ordered pair that I'm going to test. So I'll circle as a testing point, and that is 1, 0. So if I plug in 1 for x and I get 0 here, so this is 2. Is 2 less than or equal to 0? No. Okay, so we're going to go the opposite side. Alright, second line we have is going to be another solid line, and something I know about it is this line right here is a y equals, or y is greater than or equal to -1. So I'm going to find out where y is -1. So that's right here, and I need the horizontal line that goes through it. If we want it to be greater than, we will think of greater than as above the line here. And let's finish up with our shading. So I'm going to get all these values out here. Okay, so any ordered pair that you picked out here, we could plug into both of those inequalities and it would be true. Alright, the only way I can make this more difficult is to make you do more work just to be able to graph it. So, still not challenging for you. As you take a look at this one, all you have to do is add x and add x. So y is less than or equal to x plus 6. So we've got x plus 6, and we're going up. So I'm going to put 2 points here, and work backwards. Second line, we're going to subtract x this time. So you're looking at y is less than or equal to negative x plus 2. So I got plus 2, I get negative x. Okay, and another solid line. Alright. I'm going to take a look at the origin to test my first line. So I put that one in red. So 0 plus 0, 0 is less than 6. You betcha. So we're on this side because this is true. And 0 plus 0 is 0 less than or equal to 2. That's true as well. So the area shaded twice is the bottom of that x. Okay, and again, we can extend these lines out, and you start to see that there are a huge number of points that we can use. Anything in this triangle area. Solution to the system of inequalities. About halfway now. We're going to try a couple more. If you'd like to try them and then fast forward and see what the answer is, you can do that. So we're at -4. First equation's done for us. We're coming up one by one. We should also cross +4 when the slope is 1 there. We have a dashed line, so I've got to change that over to dashed. Let's go ahead and take care of our shading now as well. So I'm going to test out 0, 0. So 0 is greater than -4, right? Because this is going to become 0. 0 is greater than a negative, yes? Alright, and let's take care of this second line. Not too much work to be done. Subtract 2x, subtract 2x. We can get it all in one step. So y is less than or equal to -2x plus 2. So we're at +2. We're going down 2 and over 1, down 2 and over 1. We have a solid line because we have the equals 2 part as well. Here we go. And we're looking for some shading now. 0 plus 0 is 0, so that means I'm testing the origin. 0 is less than 2. Yeah, it sure is. So that means this is true. So I'm going to be on the true side, or the origin side of the line. Area shaded twice. That's one of my favorites. Here's the happy area over here. Anything over here will do. All these ordered pairs. Number 6. So you try and throw a bunch of stuff in there. Try and catch you, not paying attention to your signs or anything like that. That's pretty much all we can do to you right now. So negative y greater than or equal to negative 2x plus 2. You have this negative that we treat as negative 1. Divide by negative 1. Hopefully that triggers a few memories. We got to do y is now less than or equal to 2x minus 2. So I got negative 2. We're going to rise 2 and run 1. And do one more here just to get a nice solid line. Speaking of solid line, it has the equals to, so it will be a solid line. And we'll go back to that original to test things out. This makes it a little bit easier. So 0 goes in, 0, 0. That means I'm testing the origin. 0 is greater than 2. No way. Okay, so this is false, so I have to go on what would then be the true side of the line, which is the opposite. Let's get some blue in here. Subtract x, subtract x. I got negative 2y is greater than negative x plus 2. Divide by that negative 2. So y is divided by a negative less than 1/2 x. Remember, this is the same thing as saying 1 here. So we'll say 1/2 x, easy slope, minus 1. I got negative 1. We're going up 1 and over 2 this time. That's all I need. Dash line. Extend that bad boy out of there. I'll go the other way as well, just for good measure here. We are going to test out the origin. I'm going to use the original again, 0, 0. So 0 is greater than 2. Is 0 greater than 2? No way. Okay, so we're going opposite. I always want to be on the true side. We're talking about the dash line that time. Alright, so let's get shaded area. It's going to be everything out here because it's double shaded. So I always want to put some extra marking so that I can tell, or whoever's checking it, maybe the person to your left or right, when we do some work in class here, they can tell exactly what spot you meant. Sometimes what I'll do is I'll put a circle-y squiggle in there. That way you know which area I'm talking about. The only other thing we're going to ask you to do is do this entire process backwards. So you want to write the inequalities represented by the graph. Well, I don't care which line we start with. We'll call this line 1 and this line 2. Line 1, just because we made it number 1, we'll do that one first. So a couple points I want to look at. I'm looking for a y-intercept. Y-intercept is 2. So that means my equation ends with plus 2. It's always going to start with y. I'm looking for a slope. So if I have a nice point at the y-intercept and another nice point here, I've gone down 1 and to the right 1. Well, down 1 and to the right 1 is negative 1x over 1. And we don't need the second part. It's going to be shaded down here, which means if I plugged in 0, 0, it would be true. Okay, so if I make this 0, this is 0, so 0 and 2. So 0 is less than 2. That's true. So it tells me less than has to go in here. Okay, I want a true statement because the origin is part of the solution. Now, do I have a solid line or a dash line? Solid, right? There you go. You have to put the equals to on it. Alright, let's grab your second line. This one's not too bad. I have a vertical line. It goes through the x-axis. So that means it's x. It goes through at 1. So it has something to do with 1. It's shaded to the right. So just like you've been doing from the number line years and years ago, or maybe a couple months ago, shaded to the right means greater than. I have a dashed line, so it cannot be equal to. Okay, so that takes care of our system. So these two inequalities are exactly what we're after. Alright, let's try it again. This time I have two diagonal lines, so we don't have a vertical or a horizontal. It doesn't matter which one we start with. I'll call this line 1 and this line 2. So line 1, I know it's going to start with y. It's going to go through 2 again, so plus 2 on the end. I have x in here to go with the slope. It looks like we're going to go up 1 and over 1, so we have 1, positive 1 for a slope. And what we have here, if I test the origin, it needs to be something that's false. So 0 and 2. 0 is less than 2, so I need to say that 0 is greater than 2. Okay, I want to make sure that it's false. Okay, so that makes my first equation. So this is line 1. Let's get line 2 now. Y, it's going to go through negative 1, so minus 1. I need a slope. I can't tell what that is, but I can tell what that is. So it looks like we're going to go down 2 and over 1. So down 2 and over 1, but I don't need negative 2 over 1. And again, I want the origin to be false. So I have 0 going in here, 0 here, so 0 and negative 1. So 0 is actually greater than, but I want it to be false. So I need to make it a false statement. So 0 is less than negative 1. So less than, because I want it to be false again. Notice it's shaded on the other side of the origin. We have a solid line, so the only thing we have to add in here is we have to make the less than or equal to. That's as tough as it gets. Do have an exit pass tacked on here, so I do want you to try it. Remember, we have either a vertical or a horizontal line here. If you're not sure, look at the example that we did that had one of those and use your noggin from there.